in the video. So that if y'all want to look back at it, you can see here, denominators are already the same. So we're going to subtract the numerators. Now we don't necessarily need parentheses for this here, mainly because we only have one term in each numerator. We don't have x plus 2, we don't have to worry about distributing the sign. So we get this here. Now the previous one where we just had x plus 4, that is simplified. Here we have an x squared, so we need to make sure it doesn't. Difference of perfect squares. Because what times itself is 4? 2, and x squared would be x. So 4x squared is 2x and 2x. Plus and minus, fact, and our 1 squared would just be leaving us with 742. You're welcome. Yeah, I forgot to put them out. Okay. Okay. Right, because if we do have two terms being subtracted, it is always good to check for difference of perfect squares. Number 6. So let's look at it. Now, 6. Now, because the denominators are the same, we would add our numerators. Yes? Now, for it to be a difference of perfect squares, they have to be subtracted. But, okay, 3x squared, 6x have a common factor of, and if we factor 3x out of 3x squared, we have plus 2. Is there anything in common on top and bottom? No. So we're done. 741. Now, there's no reason to multiply the 3x back in. We leave it as this here. So if the numerator does factor, we want to factor it. Just in case, what's inside that parentheses became x minus 8, it came something that can be simplified. Even if it doesn't, we still need it factored. Yeah. Just to make sure, just to check. Because if it does, then we reduce. If it doesn't, we leave it. Because the only way to go further from here is multiplying the 3x back in, which doesn't really help us. 12. We want to find the greatest common factor of, least common multiple of 24x squared. Yeah. Yeah. And I'm going to try this to say this without sounding rude. The actual assignment has been posted in Google Classroom since Monday. When we started 741, I actually posted that assignment there. Yeah, so it's up there. But that's beside the point. Now, least common multiple between these two here. The first thing we need to do is factor. We need to factor these two as far as they can go. 24x squared doesn't. Now our other expression, 8x squared minus 16, we can factor out an 8x, leaving us with x minus 2. Least common multiple. So we're trying to find the first term that will make both of these be the same. Yes? So the one that's a little bit, I consider, trickier than the rest is our 8 and 24. I'm trying to see what's the first number we can turn both 8 and 24 into, which is actually 24. Now here, because we started this one here, this is problem number 12, we're looking for least common multiple of 24x squared and our 8x times x minus 2. Well, 24 and 8, the first number we can actually turn them both into is 24. Now we can look at our x squared next. And this one here, I find these a little bit easier to look at because we can just look at them. One of them has 2 x's, the other has 1. So we need 2 of them because we always take the most. Because we're going up, we're trying to go up. Because it's easier for me to go from x to x squared, I can multiply it by x, than to try to go from x squared to x. Because dividing makes things harder. So we'd rather multiply than divide, so it's easier to multiply this x by x and divide this one by x. We're going to go up. Since one of them has x squared, the other's x to the first, we're going to multiply by x, get them both to be x squared. And the only other thing missing is x minus 2. So the least common multiple for 24x squared and our 8x squared minus 16x is 24x squared times x minus 2. That's the first expression we can turn both into. Questions on this here? Huh? That's all you're looking for. For 12 through 14, you're just trying to find the least common multiple. And I will tell you, number 13, there's a good chance you're going to feel it should be more than what it is, but it's not. There's just going to be 2 sets of parentheses. There's 2 expressions that you will have. We can look at one more homework problem before we get started. So the homework was for 741, 4 through 8, 12 through 14, 20 through 23, and 26. We'll do it tomorrow. So I'm not pushing off, but that's going to take a little more time. But we can start class off with it tomorrow. And it is exactly like what we finished yesterday with, but where we started and kept having to factor and do going down from there, it won't. The numerator will not factor once we finish adding and subtracting like terms. Because I had to manipulate that equation a little while to get it to be able to factor down and have something in common. 4 through 8, 12 through 14, 20 through 23, and 26. What we're looking at today is complex fractions. Complex fractions. So our complex fractions, we have fractions in fractions. Fractions in fractions. There's 2 ways to do it. Method 1, if necessary, simplify the numerator and denominator by writing each as a single fraction, then divide by multiplying the numerator by the reciprocal of the denominator. Or step method 2, use the least common denominator of every fraction, then simplify. Okay. We have this here. We have 2 methods for doing this. I'm going to show you method number 1 with this problem. Then we're going to do method number 2. We're going to do both methods with this problem. And then I'm going to let y'all decide from then on out which one we decide to do. I have a feeling I know which one it's going to be, but we'll wait and see. So when we look at this one here, we're going to do method 1 first. Method 1 says that we rewrite each fraction, numerator and denominator, as a single fraction. And that's fine because the numerator, 5 over x plus 4, is already a single fraction. However, the denominator It is not. We have 2. Now, of our 2 denominators, we're going to be doing exactly like we've been doing the last few days. We're going to add these 2 together to turn it into a single fraction. To do that, we need the denominators to be the same. So, we need to get the denominators to be the same. And I have a feeling I would watch this. I wouldn't write this one down. Because if we're going to get these to be the same, we're going to have to multiply each of these fractions on top and bottom by a certain expression. So the one on the left has an x plus 4. What's it missing? It's just missing an x. Because the one on the left has an x plus 4, the one on the right has x. So the one on the left needs an x. Then the one on the right has x, it needs, so we'll multiply top and bottom by x plus 4. Okay, there we go. Now we have more than enough room. The numerator is still going to be 5 over x plus 4. Now our 2 denominators, one of them, 1 times x is x. The denominator should be x times x plus 4. Plus, the other side, we're multiplying x plus 4 by 2. 2 times x is 2x. 2 times 4 is 8 over x times x plus 4. Questions on what we just did? Now that the denominators are the same, we can add the numerators. So we'd have x plus 2x plus 8 over x times x plus 4. At this point here, we can combine our like terms. So in the numerator, we have 5 over x plus 4. The denominator, we have 3x plus 8 over x times x plus 4. Okay, good. All right. Did all that. Now we have one fraction top and bottom, yes? So we're going to simplify. Now, fractions, let's focus up here. It's just a fancy way to say that we're having one thing divided by another. Because if we said 1/2, 1 over 2, isn't this the same as just saying 1 divided by 2? So really, this complex fraction is the same as saying our numerator is being divided by the denominator. The top is being divided by the bottom. That's all we're saying with any fraction. This number is being divided by this number, this out of a whole. But that's helpful because if we're dividing 2 fractions, we keep the first one the same. We change it from division to multiplication and flip the second term. This is still method 1. Now at this point we can multiply. We have 5 times x, which is 5x, times x plus 4 over x plus 4 times 3x plus 8. Do you have anything in common? X plus 4 and x plus 4, leaving us with 5x over 3x plus 8. Well, we can. We don't have to multiply it at this point, but the reason I don't just go 5x times x, 5x times 4, is we need it to be in multiplication to be able to simplify. So there's no reason to multiply that out yet for our simplification process. Does that make sense? So 5x over 3x plus 8, 3x plus 8 is a single term. There's no greatest common factor between them, so I can't simplify yet. Nothing in common. with anything in the bottom, so 5x over 3x plus 8 is the final answer.
Whoa, dang.
Method 2. Least common denominator. So this came up in the previous least common denominator. Really, we're looking for what it is going to make the three denominators be the same. What do they have in common? Well, I'm going to get a highlighter out. We have x plus 4. We have x plus 4. And we have x. So really what we're looking at is we have our expression x plus 4, and x. And we're trying to get them to be the same, yes? Two of them are already the same. X plus 4, yes? So part of our least common denominator to get those two to be the same, well, they already are. It's just x plus 4. These are already the same, yes? So what does this have that this one doesn't? Well, just x. Because our x plus 4 and x plus 4 are stuck together. That's just one term. So they're both missing in x. So the least common denominator for this is x times x plus 4. Do we feel comfortable being able to get there? Yes? Okay. Right, it's missing that. Because we're trying to get x plus 4, and x to be the same. Now, if one of these, if the 5 had had x plus 4 times x plus 4 in the denominator, had it twice, we would need it listed twice. But since it's only listed once in each of the denominators, we only need it once. Okay. We good with finding that? Yes? The next step is going to seem kind of odd. Well, I'm going to rewrite this down a little bit lower. Because we have 5 over x plus 4 all over 1 over x plus 4 plus 2 over x. Okay. We have this here. Now we said the least common denominator was x times x plus 4. I'm going to multiply this whole fraction by it. So I'm multiplying the whole fraction by x times x plus 4 over x times x plus 4. Well, our part in blue, so I'd write this part down, is just a fancy version of what? 1, yes? And when we multiply this, we're going to multiply the x times x plus 4, this one here on top, by our fraction on top. When we multiply it by that, it's just being multiplied by the numerator, not the denominator of our numerator fraction. So we're not going to do any real multiplications at this point. But we'd have our 5 times x plus 4. Which we could say is what? 5x times x plus 4, yes? We do the same thing in the denominator. This x times x plus 4 is going to multiply by our 1 and our 2. Well, 1 times x plus 4 is just x times x plus 4 over x plus 4 plus 2 times x plus 4 all over x. Questions on this so far? There's a lot of stuff there, yes? It almost seems like this just got a lot more complicated than the other way, yes? Let's see what happens here. All right, we got this compy down, yes? We good with, we ready for the next step? If I look in the numerator, because we have 5x times x plus 4 over x plus 4. In the numerator, do we have something in common on top and bottom? Yes, we have x plus 4 and x plus 4. Well, that tells me my numerator is now, all of the fractions are simplified out of the numerator, yes? We can do it with the denominator. Because on the left, our x plus 4 and x plus 4 cancels, leaving us with just plus. Here, our x and x are gone, leaving us with 2 times x plus 4. Method 2 goes from our first statement, gets a little bit more complicated, and then gets way simple, all in 2 steps. Questions up to this point, how we got to 5x over x times 2 plus x times x plus 4. We do have 2 more things we need to do, and all of them are simplifying. Because we have to distribute this 2. 2 times x is going to be 2 times 4 is 8. X plus 2x is and that is the exact same thing we got on the previous one. What do y'all like better, method 1 or method 2? 2 is a lot nicer, isn't it? That's it. We find that least common denominator, and what we're really finding is what can we multiply the fractions on top and bottom to get the fractions to go away. That's our whole goal. Does that make sense? So we can look at it, and we looked at it here in the pure, let's see if I can get, almost, maybe, okay. There we go. Here, we wanted to multiply this by something so that these 3 fractions would simplify down. That was the whole goal. So we know the one on top needed at least one x plus 4 to cancel it out. Well, we have it listed once, so the one on bottom simplified too. The only thing we were missing was the x. Questions on any of this here? All right. Bless you. So we're going to do some more of these here. And I have a feeling method 2 is the method we're going to use, yes? So we need to find the least common denominator. We need to find the expression that we can multiply this by on top and bottom to make all of the fractions on top and bottom simplify out. So we do need an x minus 2. Because our x minus 2, let's get a highlighter, we'll get this top denominator to simplify, yes? So it would also get this one. Because the only time we would need more than one x minus 2 is if it shows up in one of the denominators twice or 3 times. So that x minus 2 is taking care of most of it. And we also need n x on top and bottom to simplify with this x. Now, when we multiply this here, again, x times x minus 2 is going to multiply with our numerator in the numerator of this fraction. So our 6 times x minus 2 would be 6x times x minus 2 over x minus 2. When we do this with the denominator, we're going to do our x times x minus 2 times 1, which is just x times x minus 2 over x minus 2 plus 3 times x minus 2 all over x. X minus 2. Ah, I see what you're saying, yes. X minus 2. Question how we got to this point here. Yes? Yes. No, it doesn't. Because we can just list it as x minus 2. We have a few things to simplify, yes? On top. X minus 2, x minus 2. X minus 2. X minus 2. Here we have x and x, leaving us with 6x over, a little more room. So we're not staring at the bottom of this. X 3 times x minus 2. A little bit. Now at this point here, we can distribute the 3. Our 3 times x would be 3x. 3 times negative 2 would be negative 6. Giving us 6x over 4x minus 6. Yes? Does anything factor? Because we have 6x on top. It's one term. The denominator is 4x minus 6, yes? Greatest common factor of 2. All the ones that we did with addition, subtraction, we didn't have to factor the denominator. Now, 4x and 6 has a greatest common factor of 2. We can factor it out. We haven't had to do that on the previous ones because we just factored the denominator and it stayed the same all the way through till the end. As long as there's nothing in common with our numerator term and the denominator. 6 and 2. 6 over 2 is 6 over 2 is 3 over 1. So the numerator would be x. The 2 simplifies to 1, leaving us with yeah, they're trying to get them all lined up and squared away. I think that's Mr. Shelley. Because we factored the 2 out from 4 and 6. Because when we factor the 2 out of 2x, we get, or 2 out of 4x, we get 2x, 2 out of 6, we get 3. Now, it seems an odd step to do that, but if anything factors is still factorable in the numerator or denominator, we need to factor it. Because here it worked out that we have 6 over 2. That would reduce to 3 over 1. Now, we could put the parentheses still. We don't necessarily need them with the 2x minus 3 because there's not a term in front of it to distinguish that it's being multiplied. But that's it. Now, let's just say that instead of having 2 there, it had worked out to be 5 was the number instead. And that's not working with this problem, but we just said it was 5 times 2x minus 3, and we had that set up. 5 and 6 don't reduce. So we would leave it. Even though we know that 5 it wouldn't reduce, we still want to factor it out. We still want to do that factoring just to make sure that nothing does reduce at this point. If it does, we reduce. If it doesn't, we leave it in that form. Because there's not, after we factor it and we see that if it didn't, there's no reason to multiply it back through. It's just an extra step and doesn't help. Does that make sense? Are you ready for another one of these? 6, 3, 5, 10. Yes. So 3, 10, 3, 6, 5, and 10, yes? We're trying to make them be the same, yes? This one's, once you see it, it's kind of nice. What's the first number we can turn both 6 and 3 into? Because we can do 30, but if I'm just looking at 6 and 3, there's one number smaller. 6. I can turn 3 into 6, yes? 5 and 10. 10, yes? Questions on this here? So, I mean, we are looking at the least common denominator for 4 numbers. 3 and 6 is 6. 5 and 10 is 10. So we're really looking at the least common denominator between 6 and 10. Now we can do the prime factorization as we did the other day. Well, 3 is just 3. 5 is just 5. Well, 6 is 2 times 3. 10 is 2 times 5. Now we take the most of each factor from all the ones shown. Now if I start with 2, 2 only shows up once and out of all 4. So we have it listed once. 3 only shows up once. There's 2 different spots it shows up, but in each one it only shows up once. And the last one is 5, but it only shows up once. So 2 times 3 is 6. 6 times 5 is 30. So the least common denominator between 6, 3, 5, and 10 is 30. So we're going to multiply top and bottom by 30. This is going to seem harder than it actually is. Because at this point here, we're going to multiply each of these numerators by 30. X times 30 is 30x minus x times 30 is, because we're just multiplying it with the numerator of the numerators. The denominator will have 30 times x. So we'd have 30x over, yes. I was trying to have a different hair day. Minus, the denominator for this last one will still be 10. Doing 30 times 7 is 10. Yep. The only reason we got x in those 3 other spots is, well, there was an x to begin with in all 3 spots. Questions on how we got to this point here? Now we need to simplify. 30x over 6. 30 divided by 6. 5, and we have our x, so 5x, minus 30x divided by 3. Denominator, 30x divided by 5 is 6x, minus 210 divided by 10 is 21. Now we can do 2 things. First, the numerator, 5x minus 10x, negative 5x. Now we're going to also look at the denominator, 6x minus 21. Are they like terms? No. Can I simplify it? We can factor out a 3. And if we factor out a 3, all right, yep. And 5 will divide by 3 evenly, yes? No, yeah. No, I put that out there on purpose. No, 5 over 3 does not reduce. This is the final answer. So even though nothing reduced, we still wanted to factor that 3 out just to make sure there was nothing in common on top and bottom. And negative 5 over 3 times 2x minus 7 is the final answer. That's it. It wouldn't technically be wrong, but it's still good to go on and check and make sure. And luckily with doing this one here, there's not a whole extra step where we had to actually factor it or simplify. It's this here. Questions on this here? We have time for this one here. Because here, how many fractions in this fraction do we have? 2. So, right, we have the whole fraction 3, but our two main fractions we have is 2 over x and 2 over x, yes? So the only denominators we have are x and x, yes? So what's the least common denominator between our x and x? It's just x. Yeah. And we're going to do our same step. We're going to multiply both of our terms. Now the first one, our 2 over x, when we multiply by x, would be 2x over x minus 4x. We multiply the 4 with x. We do the same thing with the denominator. Our 2 over x times x is going to be 2x over x plus 3x. X and x. Simplify out in top and bottom. So 2 minus almost and 2 plus 3x. Now, right, they are the same, but the big issue is these signs. Because we consider the 2 over x minus 4 as one term, one set term. Right, it's the whole issue with addition and subtraction. Now, if they were the same sign, this 4 would have to be 3. Now, if this had been multiplication instead, yeah, then it would just reduce to 1. 1. Because anything divided by itself is 1. Now, if it had been multiplication instead of addition and subtraction, we had 2 over x times 4 and 2 over x times 3, then the 2 over x and 2 over x would cancel. As if it had been multiplication, then we could just cross it out. But the addition and subtraction is where this changes. Now, so 2 minus 4x and 2 plus 3x. Greatest common factor between 2 and 4x. 2, which gives us 1 minus 2x over 2 plus 3x. Now, I don't necessarily need the parentheses in the denominator, but sometimes it's good to write them in there just as a reminder to ourselves that 2 and 3x are stuck together. We can't just cross one out. Yes. So that's it. It is frustrating, yes. But we have to get it into those sets of parentheses before we can start simplifying out. Because with that multiplication, we can split it apart and do like we had before, our 6 and 2, 6 over 2, which becomes 3, we multiply back in. Addition and subtraction doesn't work as nicely. Questions on this here? I have a feeling we would like to see a few more of these. Yes. We'll finish this tomorrow.